sorry about the background noise. This is the quietest area I could find. I just thought I'd demonstrate the issue since I guess it would be more useful to demonstrate it than wait for both of us to be available at the same time. So this is the issue. So I'll run the SVM code on sample_English, and these are the scores I get. Yeah. So we get 9.6, right? And then I take those vectors or those probability vectors from getproba over here, and I use them against the test labels. And what this function basically does is it just evaluates them. So it gets the argmax and then it compares them against the labels that we have for the test set. So when I do that, I get this score for the SVM, and there isn't much of a difference between them, but this is further exacerbated. The difference between the SVM and ensemble.py is further exacerbated the bigger the data is. So if I were to change this to 15k underscore examples, then the probabilities would be still quite low. While this is running, I'll demonstrate other parts. So at first I thought that there might have been a discrepancy between the test that I'm using here and the test that is being used here. So I printed the here labels._test, and I'll print the test here as well. So yeah, as you can see, the score for the SVM, it increases with 15k examples, but with 15k examples, it's supposed to be in the 20s, and this really affects the quality of our ensemble. So just to prove that the test sets are the same, so if I were to print out self. So you get 0, 16, I'll just cancel this because it's not important. Okay. 0, 16, 5, 13, 1, 8, and we get the same for the RNN. Again, did I forget self again? Yes. Yeah, so it's the same. It's 0, 16, 5, 13, 5, 13. So we're using the same test for both of them. But the SVM score is differing dramatically from what we see here. And upon further investigation, I realized that the score we output here is only based on the training set. So we only take docs_train, and we split that. So and then when we test that, we have like that small test set that we use to test, and from that we get that higher score. And then here, when we want to get the probabilities, we get it from docs.test rather than docs.train. So I was wondering if you had any suggestions on how to fix it. I think optimally we want to try to do this. Let's see where I can draw something. Can I draw here? Okay. I know we're confused. Okay, so ideally this is what we want. So the stratified k-fold, it takes the data and it splits it into train and test. Sorry, that's supposed to be TR and TE. And then it further separates it. So when we pick the K, it separates it into K sections, with all of these being test and this being train. So what we're doing here is that we're doing that, but only with the trains, not with all of with docs underscore train, and not with all of docs. While I think what we should aim to do is get split the data in a way where it would automatically split it into the test and train that we want to get it to split in. So we have to define a K value that would help us do that. I'm curious to hear your opinion on this. I'll just share the scores I got for the ensemble. So for the ensemble, alternatively, we can say that the RNN is the baseline, and we're trying to improve it with the SVM and logistic regression in the random forest. But it wouldn't really be a dramatic improvement, because let me just run the ensemble on 15K examples. Okay, was it already? No, it wasn't already. Oh, that one time I changed it. Okay, never mind. Yeah. I changed it before. It was here. Yeah, this is on 15K examples. So, So the accuracy we get we get 21.12 for the RNN, 12.8 for the SVM, and then very low scores for logistic regression and random forest. In the first ensemble, I did a voting ensemble, and that decreased the accuracy from 21 to 20.6. Of course, the accuracy would have improved had these three not been so inaccurate, specifically these two. But theoretically, the voting ensemble should be the best approach if the probabilities were close together, and the probabilities are close together in the paper. They're just not close together in the ensemble, which is what's causing the decrease in accuracy. So the other method I tried was to do a weighted ensemble. Now it increased the accuracy slightly, but that's only because I didn't really get a chance to play with the parameters. So I set lambda RNN to be 0.6, lambda SVM to be 0.2, logistic regression to be 0.1, and random forest to be 0.1. But I think if we were to change the weights and shift them around, we would get better accuracies, but it's not something I had a lot of time to play around with. So yeah, that's the issue. Let me know if you have any questions, or if you guys have any time to call.